In this video, I'll be talking about how the supreme law of nature provides strong evidence for the existence of God. But first, just briefly, I want to talk about why I love this topic and why this video kind of fits my life. I'm I admit I'm kind of a geeky guy. I loved thermodynamics in college. I majored in mechanical engineering. I did well in it. I went to nuclear power school with the U.S. Navy, where I also loved thermodynamics. Now, nuclear power school was a intimidating place. Most of the people there are in probably they were in the top third, if not higher. Maybe even the top fifth or the top 10th of mostly engineering and science programs from top universities around the nation. This is who the Navy recruits for their nuclear power school. And I thank God that He gifted me to be good at this stuff. So I was not the very number one guy in the class, but I was near the top of the class. I was in either the top 5 or 10%. But there was only one test where I got the highest score. And I remember it was thermodynamics. I just, for some reason, I've always loved thermodynamics. Later, I had an opportunity to teach thermodynamics at a university where I taught overseas. Now, I love science, I love thermodynamics, but I love God more. And eventually, the Lord called me into full-time ministry. I'm serving as a pastor now. God has given me the gift of teaching. I've always loved to teach. So when you add all this up, it's not surprising that I would eventually research evidence for God from the field of thermodynamics and then make a video where I teach about this to help others. And I want to take just a few seconds to pray. Heavenly Father, I pray that this video really will be helpful to people who watch it. In Jesus' name, amen. Okay, I'm going to turn the part off where you can see me, because I want the whole screen for the subject matter. So, over the last several centuries, we have discovered that the universe is, the physical processes in the universe are described by a number of fundamental physical equations. These can basically be written as mathematical equations. That in itself is an amazing fact. And in a way, that points, all by itself, this fact points to the existence of God, but I'm not going to talk about why that's true. Now, all of these laws are fundamental. They're all very important. But Einstein talked about a group of laws that he considered in some ways to be even more important, even more fundamental than all the other fundamental laws. Now, you might think he would be referring to one of his own laws, like E equals mc squared, but he wasn't. He was talking about the field of thermodynamics, which includes this law. This is the second law of thermodynamics. We'll talk about what it is and what it means in a minute. But let's look at this quote from Einstein. Einstein said, "A theory is the more impressive, the greater the simplicity of its premises is." It turns out that the second law of thermodynamics, even though it has huge, wide applicability, in some ways is a simple law based on simple principles. It basically says that for any physical process, the entropy of the universe increases. Now, technically, it says it increases or it stays the same, but in real life, it always, in theory, the limit of a extremely super efficient process would be that the entropy stayed the same, but in real life, it always increases. And you may be thinking, what in the world does that mean? I'll talk about that in a few minutes. Hang in there. He goes on to say the more different kinds of things it relates, and the more extended its area of applicability. So if a law explains or is related to more types of physical processes, in some ways it's more important. Well, the second law of thermodynamics helps explain why the sun warms the earth. It also helps to explain why if you put ice in a glass of room temperature soda, the soda will get colder and the ice will melt. It also explains how machines like steam engines work. In fact, the second law of thermodynamics began to be discovered when someone was studying the scientific foundation, the basis, the explanation for how steam engines work. It explains much more complicated things like how nuclear reactors work. In fact, the second law of thermodynamics applies to every physical process you have ever seen, whether natural or man-made. So it's a law with very broad applicability. This is important. We'll see this in a bit. Einstein continues and says, therefore, the deep impression which classical thermodynamics, so the second law of thermodynamics is part of classical thermodynamics. Therefore, the deep impression which classical thermodynamics made upon me, it is the only physical theory of universal content concerning which, it has universal content. I think that's saying pretty much the same thing as it applies to all over the universe, every physical process, concerning which I am convinced that within the framework of the applicability of its basic concepts, it will never be overthrown. So he thought it was possible that even his own theories, like general relativity, special relativity, could later be overthrown by new discoveries. But he was convinced that no new discovery would ever overthrow the basic laws of classical thermodynamics, including the second law of thermodynamics. Arthur Eddington was a British astrophysicist. He was the first to speculate that stars were powered by nuclear fusion, and he helped bring Einstein's theory of general relativity to the English-speaking world. He said this about the second law. The law that entropy always increases, the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. So that's what inspired my title for this video, The Supreme Law of Nature, gives evidence for God. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. In other words, he's saying that someone could come up with a new theory of the universe. It might contradict Maxwell's equations. He says, well, maybe Maxwell's equations could be wrong. He goes on, he says, if it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. In other words, even if someone did an experiment that showed that your new theory was wrong, he's like, well, maybe they could get their experiment wrong. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. His point is that compared to, now I don't think he really expected Maxwell's equations to be proved wrong, but he was saying, relatively speaking, compared to these other very important foundational laws of physics, the second law of thermodynamics is it's extremely likely to be overthrown. Now, I'm not going to explain the mathematical basis for it, but it does have a relatively simple mathematical basis, which is part of the reason that to say that the second law of thermodynamics did not apply somewhere in the universe or to some physical process, it would almost be like saying that math didn't work for that process or on that part of the universe. That's part of what makes this law amazing. Modern textbooks, science textbooks, point out a similar truth. no violation of either physical statement of the second law of thermodynamics has ever been observed in a properly done experiment. And it's extremely unlikely that there ever will be anything that violates the second law. In other words, let's see, here we go. In other words, the second law of thermodynamics applies to everything, all the time, everywhere, and it always will. The only exception being supernatural things and God. We'll get to that later. So what does this mean? What does this law mean? Well, it means entropy is increasing all the time in the universe. Every process is making entropy increase. What does that mean? Entropy is basically a measure of disorder. But let's talk about some practical things that the law means. There are a multitude of applications in physics, engineering, chemistry, and everyday life. Among other things, it means that heat moves spontaneously from hotter objects to colder objects. So, heat moves from the sun, which is hot, to the earth, which is relative to the sun, which is cool. Heat moves from the warm soda in your glass to the colder ice, and that heat will make the ice melt. And then after all the ice melts, your soda will start warming up a little bit because the heat in the air temperature in the room is warmer than the cold soda in your glass. So you say, well, that's super obvious. Yes, it is, but this law helps explain why a lot of super obvious everyday things happen the way they do. It also means that it is impossible to build a perpetual motion machine. Now, rather than give a technical definition, here's an example of what could be an attempt to make a perpetual motion machine. Imagine someone had an electric motor and they hooked it up to an electric generator. And then the electric generator went to a battery or maybe to a bank of batteries to keep it continually charged, and if it starts to get weak, to recharge it. And then the battery or bank of batteries is what powers the motor. So it goes in a loop. Now, if someone made a system like this, and they started out with a lot of charge in the battery, it might run for an extremely long time. If the motor was extremely well made with extremely low friction, same for the generator, it uses wires with extremely low resistance, it might run for a very, very long time, but it will not run forever. And the second law of thermodynamics says you cannot make any machine like that, whether it uses electricity or water power, like hydroelectric power, or some kind of mechanical power. You cannot make any machine that kind of powers itself and keeps going forever. It's absolutely impossible. People used to submit a design for machines like this to the U.S. Patent Office, and eventually the U.S. Patent Office basically mostly stopped even looking at them. They just said, there's no way, it's impossible to violate the second law of thermodynamics. It cannot happen. This system would eventually stop, no matter how well it was made. Now, what else does it mean? It means that for every process occurring in the universe, a star is shining, a plant is growing, a car is driving down the street, a volcano is erupting on a moon around Jupiter. For every single process in the universe, entropy is increasing. Entropy means for the whole universe. Locally, entropy might not be increasing, but for the whole universe, entropy is increasing. And that means disorder is increasing. And as I'll show you in a minute, that means that usable energy is decreasing. Entropy refers to the degree of disorder or randomness in a system. The greater the entropy, the less energy that is available to do work. Now, the total amount of energy does not change in the universe, but the amount of energy that can do anything, that can be used, does change. The more entropy, the less usable energy. Now we're getting to a key part of the argument. So our universe began in a condition where it had a very low entropy and a lot of usable energy. If this wasn't true, we wouldn't be here to talk about it because there wouldn't be galaxies and stars and life couldn't exist. But this is true. This is how our universe began. But over time, as stars shine, as physical processes all throughout the universe occur of all different types, the entropy of the universe is continually increasing. Every single physical process is increasing while the usable energy is getting less and less. Now, in this picture, it looks like there's still a tiny amount of usable energy, but eventually it will get to the point that, practically speaking, there is no usable energy. Long before we get to the point of absolutely none, there will be so little usable energy that all of the stars will stop shining, and there'll be no more light. The universe will be dark. The universe will become extremely cold, and it'll be impossible for any type of biological life to exist or live anywhere in the universe. Now, don't get nervous. This isn't going to happen in your lifetime or the lifetime of your great grandchildren. It's a long time from now. But this is the direction that the universe is going in, predicted by the unbreakable, universally applicable second law of thermodynamics. This has a name. We'll put the stars back up because it's nicer. This is the name that is given to this situation where the universe runs down. It runs out of usable energy. It's called the heat death of the universe. So we could think of the universe as being similar to a little wind-up car, and the little wind-up car is winding down, and so eventually it's going to stop, unless someone from outside the car winds it up. But there's no physical process that can wind things up from outside the universe. By the universe, I mean all of the matter and space and energy that exists. And so the universe is winding down. Now, if you walked into a room and you saw a little wind-up car running, but there was no one in the room, you would think, wow, someone must have wound it up. We can see that our universe is winding down. It is losing usable energy. We can predict that if no one intervenes from outside the universe, like God, our universe will end in heat death. You can Google this. You can look it up. You will, and they have a description of different stages of heat death of what is predicted to happen. Thankfully, I don't think any of us will, or any of our descendants will be around to experience that. Therefore, our universe must have begun with a finite amount of usable energy. This is important. This makes sense because entropy can only get so low. In thermodynamics, there is not such a thing as a system that has negative entropy. You might see a minus sign in front of entropy in an equation. That means that either in a local system, entropy is getting lower, which in a local system it can, but it's made up for outside the local system by a greater increase in entropy. There can be so there can be negative signs in equations with entropy, but if you look at a closed system and you just measure what's the value of entropy, it doesn't even make physical sense to talk about it being negative. So entropy can only get so low, and that means that our universe's usable energy could only be so much to begin with. If our universe began with a finite amount of energy, and it did, and if we can see that it is running out of energy and will end in heat death, then our universe could not have existed eternally in the past. If it had, it would have run out of usable energy a long time ago, and we would already be in a state of heat death. So because this is a process that even if it takes quadrillions and quadrillions of years for the universe to run out of usable energy, because it's a process that does happen in a finite period of time, it means that our universe can only exist for that amount of time before it's in heat death, and that means it cannot have existed longer than that going back into the past. So our universe had to have a beginning in time, an absolute beginning. In other words, the second law of thermodynamics, which is one of the most trusted and foundational and widely applicable laws in all of physics, provides evidence that our universe had a beginning. Now, this is true whether or not the Big Bang model of the universe is correct. There's a lot of evidence to support the basic idea of the Big Bang model. The details are constantly being adjusted. I think it's probably basically correct. I think that's probably how God made the universe. But even if the Big Bang model is true, it's not true. This theory would still say the universe had to have a beginning. It only requires basically two things: that the universe be a closed system. And because by the universe we mean all the matter and energy in space that exists, the universe is a closed system, with the possible exception of God. I believe that God exists, so God is outside of the universe. He exists everywhere. He's also here with us. But when you take God into account, he can intervene in the universe, and that can change things. But not taking God into account, the universe is certainly a closed system. And number two, the second law of thermodynamics must not be violated. But we've never ever seen it violated, and there's no scientific reason to think it ever has been or ever will be, again, unless God is doing something supernatural, something above the laws of nature, something beyond them, what we would call a miracle. Aside from that, and it doesn't seem like God does that very often, the laws of nature are extremely reliable and extremely predictable. So as long as those two things are true, it means that our universe had to have a beginning. And if the multiverse exists, there's no evidence that it does. I don't think it does. But if it does, then this argument would apply to the whole multiverse. In other words, our individual universe would be part of a vast multiverse with lots of individual universes, but the whole multiverse would have to have a beginning. This argument would apply to the whole multiverse unless one posits that somehow the second law of thermodynamics that applies everywhere, always, and to everything, and we know about this, unless somebody says, well, somehow it doesn't apply to the multiverse. There is no reason to believe that, although some have tried to make models based on that highly speculative assumption for which there is no evidence whatsoever. So this is evidence for the existence of a great, powerful, ancient creator God, the fact that the universe had a beginning, who exists independently of and existed logically prior to the entire universe. How? How does the fact that the universe had a beginning give evidence for God? Well, to see this, we need to think about the column cosmological argument. This is how it goes. It has two simple premises and a conclusion in part one, and then there's a part two. So it says anything that begins to exist has a cause. Number two, the universe began to exist. And then, very simple logic says if 1 and 2 are correct, number 3, the universe has a cause. And then part 2 of the argument says that because the universe is all matter, all energy, all space, so nothing having to do with matter, space, or energy could have created it. So the most likely cause for the entire universe, including all space and matter, to begin to exist is God. Now, when I think of evidence for God, I don't think of absolutely 100% certain ironclad proofs. I think about evidence that makes the existence of God much more likely than the non-existence of God. And I think that this argument shows that God is much more likely to exist than to not exist. And the second law of thermodynamics helps us by giving us really good, strong evidence that the universe began to exist. Let's go through the argument one more time. Anything that begins to exist has a cause. This is our universal experience. If you see a baby kitten, you know it didn't pop into existence for no reason. It had to have a cause, namely a mother cat and a father cat. If you see a car, you know it didn't pop into existence. You know that it had to have a reason for existing. In this case, you have a good reason to believe that the reason is that people made it in a factory. If you see the planet Mars, you might not know what the reason is that it exists. But if you know that it began to exist, it didn't exist eternally into the past, and it didn't because the whole universe didn't, you know that something had to cause that planet to come into existence. And then you could look up different theories of where the planet Mars came from. Even if you believe in magic, except for God doing supernatural things in the world and angels and demons and things like that, I don't believe in what people normally mean by magic. But if someone sees a magician pull a rabbit out of a hat, they still believe there's a cause. They believe that there's a magician, the hat, and magic. They don't believe that the rabbit appeared for no reason whatsoever. Of course, most of us believe that the cause was some kind of a trick. That's what I believe, and it had nothing to do with magic. The point is that anything that begins to exist has a cause. Most people don't deny that premise of the argument. The second premise is that the universe began to exist. Now, 120 years ago, a lot of scientists did not agree with this. And even today, this is the premise of the argument that people try most often to deny. But the second law of thermodynamics gives us strong reason to believe that it's far, far, far more likely that the universe does have a beginning than that the universe has existed eternally into the past. And then the final point is just a simple logical deduction. If number 1 and number 2 is true, then number 3 has to be true, or else there's no logic. Logic doesn't work at all. The universe has a cause. Now, why is God the most likely explanation, the most likely cause? Well, again, the cause can't be anything physical because everything physical is what came into existence. Also, if the cause was some kind of a non-personal process, then it raises an answer that's very difficult to answer. A non-personal process can't choose when to act. So it raises the question of why is our universe only about 14 billion years old? Why didn't if the non-personal process was going to cause the universe to come into existence, why didn't it do it 100 billion, 100 trillion, 100 quadrillion years ago, in which case we'd already be gone. We wouldn't be alive anymore. So for a number of reasons, God is the most likely explanation if the universe had an absolute beginning. And the second law of thermodynamics is evidence that the universe did have an absolute beginning. So have scientists recognized that the second law of thermodynamics implies that the universe had a beginning and that this in turn implies that God exists? Well, yes, I'm not saying that all scientists have recognized that, and certainly there are scientists who argue against that, but scientists have recognized that. And at this point, I want to call on a hostile witness. A hostile witness is a witness who disagrees with you, but who nevertheless gives evidence that supports your argument. And I'm talking about I.P. Bazarov. He was a Russian scientist who lectured widely and wrote books on thermodynamics. Some of his books were translated into other languages, including English. Now, Bazarov lived when Russia was still part of the Soviet Union. In the Soviet Union, scientists who supported views like the Big Bang, which also implied that the universe had a beginning, and thus implied that it was created, were imprisoned, shot, put under house arrest, and committed to insane asylums. Some of them were put in insane asylums, some were in prison, some were shot. Some managed to escape out of the country. This is very well documented in a book I'm reading now called God, the Science, the Evidence. I'm not through the whole book yet, but the part I've read so far is excellent. It mentions this thermodynamic argument. In my opinion, I don't think they explain it quite as well as I'm doing, but they give a good explanation, and so far I think it's a good book. But anyways, they do a great job documenting this terrible history of these scientists being persecuted when they taught or held to views that implied there was a God, because the Soviet Union was based on atheist communism, and they viewed any belief in God to be a threat to their system. So it's little wonder that Bazarov argued against the heat death of the universe, which implies it had a beginning and therefore a creator. But let's look at some of what he wrote. I'm going to read a few paragraphs. You can skip this part if you want, but I think it's interesting. The results of thermodynamics have the advantage of being based on the most general empirical laws without being tied to any particular conception of the properties of the particles that make up a system. Then he continues, the relations of thermodynamics are indeed true for all statistical systems. So, like other scientists, he's saying, wow, thermodynamics, basically he's saying, if there's a system of particles, and particles can mean atoms, molecules, in other words, anywhere in the universe, because the whole universe has particles in it, he's saying any system of particles, thermodynamics applies. And there's very foundational, strong reasons to believe that this is true. Now, he also writes, the theory of thermal death of the universe was explicitly formulated about 100 years ago by Clausius. Now, he was writing this, Bazarov was writing this in the 1960s. So for us, this would be about 150 years ago. Clausius, who, by extending the law of thermodynamics to the entire universe, wrote, the energy of the world remains constant. The entropy of the world tends to a maximum. So the total amount of energy is the same, but because entropy is increasing, usable energy is going down. This meant that the universe will sooner or later arrive at a state of thermodynamic equilibrium. Then all process will cease and settle down in a state of thermal death. So Bazarov recognizes that if the second law of thermodynamics applies to the entire universe, then it's correct to predict the thermal death of the universe. But then he writes, since then the pseudoscientific theory has obtained fairly wide acceptance in Borgese scientific circles. Okay, what he means by Borgese scientific circles is scientists who are not communists, who are not living in the Soviet Union or another communist nation. He's saying, well, a lot of them agree with this heat death stuff, which predicts the end of the universe. He then explains why he thinks this is a bad thing. He says this theory of thermal death leads directly to religious superstition, to the existence of God. He knew that if the second law of thermodynamics applies to the universe, it implies that gods exist. He continues, in fact, since, according to Clausius, the universe moves continuously towards thermodynamic equilibrium, while it is not in an equilibrium state at the present moment, then it follows that either the universe has not always existed, that is what I explained in this video. The universe has not always existed and has been somehow created, or some sort of external force has at some time removed it from its equilibrium state, and we are now living in the epoch of returning the universe to a state of equilibrium. This means that God must exist. That's what Bazarov wrote. He doesn't agree that it's true, but he realizes that if the second law of thermodynamics applies to the whole universe, he realizes that this means that God must exist. That's his conclusion, even though he argues against it. He writes, the reactionary views of Clausius have been subject to Engel's crushing criticism. From the positions of dialectic materialism, Engels proved the complete inconsistency of the theory of thermal death. Who is Engels? Is he another great scientist? Was he an expert in thermodynamics? No. He was the close friend of Karl Marx. He was one of the people who, together with Marx, laid the philosophical foundation for communism. And what he did is he tried to apply the philosophical basis of communism to thermodynamics in order to prove that the theory of thermal death is wrong. Now, I'm not going to take you through his arguments. You can look them up yourselves. I will just summarize by saying his arguments are terribly bad. I wonder if Bazarov really believed that Engels had successfully shown that thermal death was false, or maybe he convinced himself this must be true because if he came out and said it wasn't, I mean, he was literally in danger of being put in jail or killed or put under house arrest at least, or maybe he secretly believed in the thermal death of the universe, and he wrote about it in a way that could get people to think about it, while on a surface level saying that it's not true. To me, that kind of feels like what's going on. I lived in a country for 14 years. It was a Muslim majority country. When we first got there, it was under what was essentially a type of dictatorship. Technically on paper it was a democracy, and people were afraid to speak out about things they believed in, contrary to the government. So they would do it in kind of indirect ways. Maybe that's what Bazarov is doing, or maybe he had talked himself into believing this. But the point is that even though he is hostile to the view of thermal death of the universe, he agrees that if the second law of thermodynamics applies to the whole universe, it would be true, and it would imply the existence of God. And he himself says that basically the second law of thermodynamics applies to any set of particles, which the universe is a big giant set of particles. So, hostile witness that I think shows that yes, there were scientists who realized what the second law of thermodynamics means when it comes to God. Yes, the theistic implications of the second law of thermodynamics have been seen by many scientists. Now, I will tell you there are many scientists who will argue against this. I'm not saying all scientists believe in God because of this. That's obviously not true. They should, though, in my opinion. But this was seen by many scientists, even scientists who could not, at the risk of their lives and freedom, at least agree openly with such implications. Okay, there's a little bit more. So the second law of thermodynamics is evidence that the universe began to exist, but there's a lot more evidence than this. For instance, Einstein's theory of general relativity implied that the universe was dynamic and that it did not always exist, and then later there was observational evidence to support this from Hubble seeing the redshift of galaxies. So Einstein's theory of general relativity gives evidence that the universe began to exist. And then there's a relatively new scientific theorem called the BGV theorem. That's named after, the letters come from the three guys who worked on it, Bord, Guth, and Vilenkin. That is a very broadly applicable theory that says that any universe, any multiverse, any cosmos that on average is expanding, and most of the models of our universe is expanding. In fact, our universe is expanding at an accelerating rate, and there probably isn't a multiverse. But if there is, most models of the multiverse involve an expanding multiverse. And they said if any universe, multiverse, cosmos is expanding on average, It's impossible for it to have always existed eternally into the past. It had to have a beginning. So there are multiple lines of independent evidence that the universe began to exist. And there's more than this, but these are three of the top ones. Now, in addition to that, there's another separate way in which the second law of thermodynamics gives evidence for God. The second law of thermodynamics, and more specifically, the realization that our universe must have began in a state of very low entropy, provides one of the most stunning examples of the fine-tuning of the universe for life. And I will include a link to a video where I talk about the fine-tuning of the universe. But let me explain this briefly. So remember, I showed this picture of what the universe was like when it began. It has a very low level of entropy. Actually, you can't really make a good scale in a slide this size. It's amazing how low the entropy was at the beginning of our universe. And that meant it had a lot of usable energy, which allows us to exist, which allows us to live. Now, this very low entropy state at the beginning of the universe, this is super amazingly unlikely. And yet, if it were not true, our universe would not be able to support life. Roger Penrose, who won a Nobel Prize in physics, calculated that the chances of the universe starting with this low entropy state that it actually did start with are 1/10 raised to the 123rd power. This number is probably the smallest number you've ever seen. It's way smaller than a trillionth. It is super small. It's the chances of this happening are just randomly way less than if you bought one lottery ticket in a fair lottery like the Powerball lottery, and you won, and you did that 10 or 20 or 30 times in a row. The chances of winning that 10 or 20 or 30 times in a row are way trillions and trillions of times more than the universe starting with this low entropy state. So, a good explanation for the fine-tuning of the low entropy state at the beginning of our universe is that our universe was created intentionally to be a home for creatures like us. In other words, God did it. A final thought: the existence of God means that the universe does not have to end in heat death because it is not ultimately a closed system. In terms of physical stuff, it is a closed system, but God can operate outside of the system, outside of the laws of physics. God can intervene and either renew our universe so that it keeps going, or create a new one and bring us into it. And just as the universe does not have to end in heat death, your end does not have to be death and decay. The Christian hope of resurrection to eternal life makes sense when we see evidence of a creator and then look at other evidence, not shared in this video, that Jesus died for our sins and rose from the dead. I'll end with a Bible verse. But according to his promise, we are waiting for new heavens and a new earth in which righteousness dwells. May God bless you.